Yeah, right. So today we are going to be graphing and solving linear inequalities. Love it, love it, love it. So there are 5 inequalities out there. Okay? So a picture of what they all look like. A less than looks like that. You've seen it before. A greater than looks like that. Okay. I call those the alligators. Okay. Remember, they like to eat the big numbers or the bigger things. So I call them alligators. Less than or equal to, greater than or equal to, I call those the crocodiles, because crocodiles are meaner than alligators. And then the last one, which it's a rarely used, rarely seen one, is the not equal to, which is an equal sign with just a slash through it. Okay, so those are the 5. Now, they get treated a little bit differently. Okay? When we're graphing them, so when we're going to be graphing inequalities today, it's not like I'm talking a full-scale Cartesian XY graph. I'm talking number line graphs because we're dealing with linear stuff today. So we're dealing with one variable. Okay? So we graph it on a number line, and there's 2 parts to that graph. So the first part is the dot. Okay? So the dot that goes on the number line. If it's filled in, those are the crocodiles. Less than or equal to, greater than or equal to. If it's open, it's just a circle, those are just less than or greater. Because what that's saying is the dot filled in means you're including that number in the solution. So that only happens in the equals case. Okay? Then the second part is that there's going to be an arrow going in one direction. Okay? So what I mean by that is, so if we had like x is less than 7. Okay? The only number that I care about on my number line is 7. Now, if you wanted to put more numbers on your number line, that's up to you. The number that needs to be on there is 7. Okay? Then, because it's less than, that means I'm going to have an open circle right around that number on the number line. And I want numbers smaller than 7, so those are numbers to the left of 7. So that's what your graph looks like. I would also accept, in this particular case, I would accept that as an alternative. Okay? The one that I don't want to see, and mainly it's because you are probably on monocolor, because you're either just using up pen or up pencil. You're not going crazy funkified colors. Okay? So this is what I don't want to see. Because I can't tell which way your arrow goes. Okay? Now, if you want it to go like this, that I can handle, okay? Because I can see which way you're talking, okay? But it's got to be visual. Okay? So this one don't like it. Okay? And you've done all this stuff. Okay? When we're going about solving an inequality, it is no different than when last week we were solving equalities. What we do to one side, we do to the other. To move something, you got to do the opposite. We want to get variables on one side, numbers on the other. All that stuff is all the same. The only difference is that when you're in an inequality, if you multiply or divide by a negative number, not just multiply, not just divide, it's got to be multiplied or divided by a negative number. The sign literally flips around. Okay? So if it was greater than, it becomes less than. It doesn't flip-flop between the equals and the non-equals part. Okay? It just the sign literally just rotates itself around. Okay? And we'll have a bunch of these today where you'll be able to see what I'm talking about. But we can't forget that. Classic mistake. Okay? One of the things that I will always point out for you is I'll point out where you're going to make the mistake. The reason I do that is because I don't want you to make the mistake in those points. So I point out where I've seen these mistakes being made over the course of my, 20 plus years of teaching the maths. Okay? Okay? Let's do it. Dive into it. Solve and graph. Solve and graph. We'll start with a couple of easy ones here first. So 4x is greater than or equal to 24. So the first thing that I would do is I would divide both sides by 4. As long as I do it on both sides of the inequality, mine is great, grand, and wonderful. Am I dividing by a negative? No. So my sign will stay the same. So the solution here is x is greater than or equal to 6. The graph of that would be a number line. The only number that I care about is 6. Would I have a open or closed dot? Closed because it has the equals part. So I have a closed dot at 6. And is my arrow going to be going to the left or to the right or straight up? Or straight down? Raya says left. Do we agree with left? Oh, I've heard a right. Because we want bigger numbers than 6, right? And bigger numbers happen on the right. Sorry, Raya. And that's that. Did we divide by a negative?
No.
Then no. Remember back like 5 minutes ago where I said only when you divide by a negative, not when you just straight up divide. Mm-hmm. Now, later on this week, we're going to talk about interval notation too. Okay? And this one in interval notation would be a bracket at 6. And it would be going out to infinity. But we'll talk more about that later this week. Okay? All right? What would you do first in D? Subtract 8 on both sides? then that gives me negative x is greater than 9. What will we do next? Divide 5 by negative 1. Now, that's the kicker, because now here we are dividing by a negative. We could have also multiplied here by negative 1, but that's the kicker. So my greater than symbol now becomes a less than symbol. So the graph of this one would be, the only number we care about is negative 9. Open or close circle. Open. Arrow going left or arrow going right. Goes left because it's less. Number small. Okay. Interval notation on this one. Again, this is going to come next week or later this week, but the interval notation on this one would be negative infinity to negative 9 with parentheses. The infinity is an interval notation. Always do a parentheses, unless you're Chuck Norris. All right, try those two. All right, so first thing I would do, and again, you don't have to necessarily do it my way, but first thing I would do here is I would subtract 2 from both sides. Then that gives me 10 is less than or equal to negative 4x. Then I would divide both sides by negative 4. Again, saying to myself, ding, ding, ding. That is going to flippity-floppity my inequality. And 10 over negative 4, reducible fraction, negative 5 halves. Both can be divided by 2. Okay? Now, this fraction doesn't matter. We can handle whatever fraction we can because that's the only number that's going on our number line. So this could be negative 5 halves. It's a number still on my number line. Closed dots here for that one. And we want that to be the biggest number. So that means we are going to the left step. Questions on that one? Talk. I did. You went from eating the right side to eating the left side. Mm-hmm. You had me nervous there for a second, as if I forgot to flip the side, and I'm like, I did. Okay. On this one, the first thing I would do is I would distribute my 5. Then I would subtract 5x to get the x's all on the same side. If you wanted to, you could add 6 to both sides to get all the numbers on one side. But ruh-roh, what happens here? We've got 0 is less than or equal to 11 with no variable. Is that a true or a false statement?
False. True. False.
Is 11 bigger than 0?
Yes.
So then that's a
false.
Give me another.
True.
Is 11 bigger than 0? You are literally just throwing out any word possible right now.
Because you keep asking me, so, okay.
Is 11 bigger than 0?
Yes.
So is that a true
Yes.
statement then?
Yes.
So that would be true.
Yes.
Okay. True, I like that better. So a true statement without variables, that gives me all real numbers for infinite solutions. Well, what would the graph look like? Actually, it's just all it is. You put any number you want on there. I'm going to put 11. And it's just a line going in both directions. It's the only time you get a line in both directions. You should put the word "or" here. Cute. Compound inequalities are two inequalities in one problem. Okay? Now they come in two different forms. Okay? The first form is an AND statement. -4 is less than or equal to x, and x is less than 8. They also come in an OR statement, where x is less than 3 or x is greater than 7. One of them is a handle, is what I like to call it. I call it a handle. Okay? And that's this one. Okay? So this one I call the handle. And here's why. When we go to graph it, we're going to graph -4 is less than or equal to x, and x is less than 8 on the same graph. So how that's going to look is, that's going to look like now I've got two numbers that need to be on my number line because I've got two parts. The -4 is going to have a filled in circle. The 8 is going to have an open circle, just based off of their inequalities at those particular numbers. And so this one up here tells me that I need to be numbers bigger than 4. So that's going that way on the number line, right? But this one down here tells me I need to be less than 4, or less than 8, excuse me. So that's going to be to the left. So the handle part comes in because that's exactly what it looks like. It's just that one little section of the graph. Questions on it? We'll get into a little more complicated ones where we'll have to do some math involved with it, and then, all of our great algebra rules and stuff like that to get it to that point. The interval notation for this one, would be bracket at -4. Almost put infinity. Parenthesis n. Okay. Now, the secondary reason that I am wearing some Minnesota gear today is because I call this one the RTB. We're rowing the boat, okay? Which is Coach Flex say he's the Minnesota football coach. Okay? He wants to get in the boat and help row the boat. Okay? So on this particular one, we're going to deal with them. That was bad. We're going to deal with them individually. So x is less than 3 would have an open circle at 3, and it would be going that way. X is greater than 7 would be like that. So it literally looks like the oars of a rowboat, okay? Which is why we're rowing the boat. Okay? This interval notation is a little more complicated because this left section is from negative infinity all the way up to 3. The right section is from 7 to positive infinity, and then you got to put a big old U in between them because it's the union of those two sections. Here now, in the handle case, you might have to do some work. So like for instance, if this were just one inequality, I would want to subtract 5 to get it away from the x value. Okay? The downfall is now you've got 3 parts of your expression, so we've got to subtract that in all of the parts. Okay? So you've got to do whatever, it's not just what you do to one side, you got to do to the other. Now it's what you do in one part, you got to do in all parts. Negative 10 minus 5 is negative 15. Is less than 3x. Is less than 8 minus 5 is 3. Next, we would want to divide by 3, which means I've got to divide by 3 in all cases. If I were dividing by negative 3, which I'm not, but if I were to be dividing by negative 3, both of those inequalities would flip. Okay? Not just one. I have to flip them both in order to get that going. Okay? Negative 15 divided by 3 is negative 5. 3 divided by 3 is 1. So that is my inequality. My graph, then, would be open at negative 5, open at 1, and it would be a handle there. In the OR case, you just treat it like normal. You just do each one individually. So you would add 1 to that one first. Then you would divide by 2. Then you would go over here and you would subtract 3. Then you would divide by 4. And then you would write it out x is less than or equal to -3, or x is greater than or equal to 1. And then that is RTBing, filled in dot, that way, filled in dot, that way, and there we go. Questions on that? That's all I got for today. Again, if you didn't pick up the blue worksheet, pick up said blue worksheet for today. On said blue worksheet, it's only one side today. You can do 1 through 4. So far, 1 through 4.